instrumentation lab. We are having here gas chromatography, HPLC, and also particle size analyzer for the use of postgraduate students.
So welcome to the lab bioprocess. So here we normally do the experiments on wastewater treatment, biological methods, and as you can see, we have a section where we do the process analysis for the sample preparation, as well as at the back there we will have reactors for the wastewater treatment.
So at this section is to analyze the samples. At the moment I'm analyzing the pH of the samples collected. Setup of my experiment about the CWMFC system, the constructed wetland microbial cell. I'm using this system to treat the format. So currently I'm using the system to analyze the quality of the influent and effluent of the format.
So I'm going to explain about this reactor. So here we have a high pressure reactor which is used for liquefaction process. So currently for my research, I am doing liquefaction of plastic into valuable liquid product. Previously they have used this for liquefaction of rubber as well. So that is basically in general what this equipment is about.
Sulaiman Sari, PhD student, Chemical Engineering Department. My work actually represented and fabricated a nanofiber material from a photocatalyst material to splitting the water and evolution hydrogen under a simulated solar system. This is the first part of the fabrication. After we fabricated the nanofiber, after we fabricated our material, we loaded it over a copper electrode, actually to test its performance. By photocatalytic cells to evolution the hydrogen by splitting the water using a suitable irradiation device, and we collected the evolution gas by water displacement method.
Here we have a few setup to prepare optical fiber for sensor experiment. This one is actually how we make the microfiber, that we reduce the diameter of fiber to around 1 or 2 micron. And this setup we make actually to polish the fiber so that we can make the fiber this shape. So this shape fiber for sensor experiment. So after we prepare, so we characterize the thing with camera, so we can see the dimensions of the devices. Okay. Here we have some material characterization equipment. We have centrifuge, we have hot plate, and also furnace for sensor experiment. Mostly for the sensor experiment. Also the facilities for developing ultra short pulse laser, fiber laser. So here is actually the fiber laser setup that we do some experiment on that. So this one, the cavity, we call the laser structures or laser cavity. So this actually the pump source for the laser, and then we characterize in the wavelength domain using the optical spectra analyzer. In the time domain we use the oscilloscope, and also in autocorrelator actually to measure the pulse. We also characterize in the frequency domain using the RF spectrum analyzer. We have developed high power fiber laser for welding applications. Here how we welding the two steel, and we developed the welding machines here that consists of various components, like we have a pump here. So this is some of the pump that we use for high power fiber laser for welding applications. So this lab actually for the developing high power laser systems.
Here we do 2 micron fiber laser. Here as a source we use the backlight erbium ytterbium to pump the thulium green fiber in this cavity. So this cavity will produce 2 micron wavelength, and the wavelength will visualize in a spectrometer here. And then for radio frequency spectrum analyzer, here we will see the radio frequency domain, and here for the oscilloscope we will see the time domain from the cavity of 2 micron.
Okay, I think this our CO2 laser. So CO2 laser actually consists of tube that contain the CO2 gas here, and we have a flash lamp here as a pump. Okay, so flash lamp is operated by controller, so this controller, and we need to cooling the system. So during operation we need to cooling, so we have a water cooling system here that we flow water inside the system. So this laser can produce, I think can generate a 50 watt output power.
Assalamualaikum. Hi, you guys in lab, heat engine lab in University Malaya. So we have 3 types of different engine. We have single cylinder and we have the petrol and gasoline. Mainly in this lab we look into the performance of biodiesel that being produced by our student, and we investigate all the performance of the engine. This is a Kia Spectra engine, mainly for the petrol engine. For the undergraduate student, we run to test the performance of the normal gasoline, but for the postgraduate student, we look into the performance of the bioethanol that been produced by our student.
Hello, good evening. This is our chemical lab located in mechanical engineering department. Since it is located in the mechanical engineering department, all students have to go through a safety seminar before they can use this laboratory. And in this laboratory, particularly, we are interested in various kinds of technology for biofuel production, using different types of catalysts, different setup like temperature and so on. So in this lab, candidates have the ability to try out various processes at lab scale before they scale up into biofuel that can be tested either with internal combustion engines or other types of machinery.